All right, welcome back to Mathematics Meal. We are still on the business of salt. Yeah, still on the business of salt. You see, salt is a very big topic, just like any other topic in mathematics. It's not something that we have to rush, so that's why we have decided to break it down into different parts, so that if you are able to follow our videos from the first part to this part, there's nothing that will make you not to understand the concept of salt. We are trying to empower you so that you can trample upon all snares and scorpions that you may meet in salt, so that no sword shall by any means harm you anyway. Yeah. So last time we considered rationalization of salt, and we are still looking at rationalization of salt. Yeah. We want to consider illustration questions too. In the first set of questions, we considered salts where the denominators are what? Monomial salts. For example, we have 4 all upon square root of 6. Something like this. We just have monomial salt as the denominator. So in this part, we are going to look at how we can rationalize salts when we have binomial salts as the denominator. All right. The steps still remain what? The same. Yeah. That's why I have to leave the steps so that we'll follow it. Yeah. In case you have not watched our videos, there is need for you to watch our videos. Just take time from the first part of salt till now. It will help you a lot. Yeah. All right. Let's begin and let's begin and let's begin. Okay. We have the first question. We have 1 divided by 2 minus square root of 3. Okay, this is a binomial salt. It's not like the previous salts that we encountered when we are trying to rationalize salts with monomial denominator. So what are we going to do in this process? Still the same step. Take note of the fraction. We have taken note of the fraction. That's this. Say obtain the conjugate of the denominator of the fraction. So let's go to the denominator. Wow. What will be the conjugate? I can hear someone trying to say, oh, in the first set of questions that we saw, the conjugate is the radical. So let's still take the radical. And in this case, the radical is square root of 3. No, no, and no, and no, and no. Square root of 3 is not the conjugate. Why? This is a binomial salt. So the method of finding the conjugate of binomial salt is not the same. The rule of finding the conjugate of binomial salt is not the same rule as in what? Monomial salt. So what is the conjugate of 2 minus square root of 3? The conjugate of a binomial salt is obtained by changing the sign, separating the two terms to the opposite sign. So in this case, I have 2 minus square root of 3. So the conjugate will just be 2 plus square root of 3. So to obtain the conjugate of a binomial salt, change the sign separating the two terms to the opposite sign. So now I have minus. The opposite sign is what? Plus. So 2 plus square root of 3 is the conjugate of 2 minus square root of 3. Watch part 8 of salt. You will understand this concept. So the conjugate, they say obtain the conjugate of the denominator. So the conjugate of this should be this. What are we going to use the conjugate to do? That's what step 3 is telling us. That we use the conjugate to multiply the numerator and the denominator. So we have our salt, 2 minus square root of 3. Then we multiply the numerator and denominator by the conjugate. That's 2 plus square root of 3 divided by 2 plus square root of 3. Okay? When we multiply this, it remains the same. When 1 multiply this, so we are left with 2 plus square root of 3 all upon. These two salts are conjugates, you remember? This is the conjugate of this, and this is the conjugate of this. So this is a conjugate, this is a conjugate. In part 8 of salt, I gave a rule for multiplying conjugates. When you want to multiply binomial conjugates, please don't stress yourself on the expansion or algebraic expansion. I know, but since I want to multiply this, I will just say 2 minus square root of 3 times 2 plus square root of 3, and then I will start expanding. Oh, it's still okay that you do that. But once you have conjugate, remember, if they are conjugates, It is only when they are conjugate that the rule I want to give you, I mentioned that rule in part 8. It's only when they are conjugate that the rule I want to give you now will be applicable. If they are not conjugate, please carry out the normal expansion. But if the salts are conjugate, when you have conjugate salts, that's binomial salt that are conjugate, please remember I'm talking about conjugates. Not when I have maybe 3 plus root 5 into 2 root 3 plus 2, something like this. These two salts are not conjugate anyway. They are not. So you cannot apply the rule I want to give for conjugates in a situation where the salts are not conjugate. So the rule I want to give now is for conjugates alone. So if I want to multiply this times this, all I need to do is to square the first number, use it to subtract the square of the second number. Very simple. That's what I'm going to do. The square of the first number minus the square of the second number. The first number is 2. The second number is root 3. So I will square these two, use it to subtract the square of 3. Very simple. The first number is 2. The first number is square root of 3. So that's what I will do. So I will just do to multiply this and this because they are conjugate. I know why I'm shouting this. So that you will not meet a multiplication of binomial salt and they are not conjugate and you start applying this rule. No, it will not work. This rule is only applicable for conjugate. I can hear you say that. So let's look at this. 2 squared minus square root of 3 all squared. I'm multiplying this and this. I am doing this because that's the rule for multiplication of binomial conjugates. So if I do that, I have 2 plus square root of 3. 2 squared will give me what? 4 minus square root of 3 squared. Square root of 3 squared means square root of 3 times square root of 3. And root 3 times root 3 will just give me my beautiful 3. So this squared will give me 3. So I will be left with 2 plus square root of 3 all upon 1, which is exactly 2 plus square root of 3. Beautiful. Beautiful. And beautiful. Absolutely beautiful. Mathematics is very sweet. Very sweet. Very sweet. Very sweet. Imagine when you are taking these steps. If you understand the steps and you are taking them, you just be enjoying yourself. You just be enjoying yourself. Even if you are sleeping, you can just dream of where you are solving these problems, enjoying yourself. Okay. So let's quickly go to the second question. The second question, question number 2. Question number 2. We have 3 square root of 7 all upon 5 minus square root of what? 7. So we have taken note of this, right? Yeah, we have done that. So obtain the conjugate of the denominator. Now it's still a binomial sum. So the conjugate will be 5 plus square root of 3. Just change the square root of 7. Just change the sign to the opposite sign to get the conjugate for binomial sum. So we have 3 square root of 7 divided by 5 minus square root of 7. A conjugate is this. We have obtained the conjugate of the denominator. So we use this conjugate to multiply the numerator and multiply the denominator. So times 5 plus square root of 7 all upon 5 plus square root of 7. I'm using the conjugate to multiply the numerator and the denominator. We move. Okay. If we multiply 3 root 7 times 5 plus what? Square root of 7. So this times this will still open up the bracket. All upon. Now these are conjugates. We still apply our rule again. The first number is 5. I square it. The second number is square root of 7. I square it. I subtract them. So to multiply this and this, I will just do 5 squared minus square root of 7 squared. Why am I doing this? They are what? Conjugates. And when I'm multiplying binomial conjugate, I use this rule. That's the principle of difference of 2 squared. Okay. 3 root 7 times 5. That's opening the bracket now. What will I have? Let's see what I will have. 3 root 7 times what? Ordinary 5. 5 will multiply 3 because this is ordinary number, so they can multiply. I will have 15 root 7. 5 times 3 is 15. Remember, it's no longer news that you cannot use 5 to multiply what? Square root of 7, because this is ordinary number and this is sod. So there's no way 5 can multiply that. You can count the number of times I've said this if you have been following our previous video, if you have followed our previous video. So we have 15 square root of 7. Okay, now this times this, that's the next thing we'll do. 3 root 7 times what? Square root of 7. What are we going to have? We now have 3 root 7 times square root of what? 7. Let's see what we have. Square root of 7 can multiply square root of 7 because they are solved. So I have 3 times square root of 7 times square root of 7 is 7. We have said that when a radical multiplies itself, it gives us the number in the radical. So we have this. 3 times 7 will give us what? 21. So I will have plus 21. That's 3 root 7 times this. Divided by 5 raised to power 2 is 25. Minus, okay, we look at this. Square root of 7 squared. That's what we have. Square root of 7 all squared. It means square root of 7 times square root of 7. And square root of 7 times square root of 7 is 7. We have this. Nothing to do here. We can see it. So we'll bring it down. 15 root 7 plus 21. We can subtract this. So this will give us 18. Okay. That's what we have. Now I can break this down further. Just look at this. If I look at this, 3 can divide 18, 3 can divide 15 and can divide 21. So 3 is common. So if I factor 3 divide 15 will give me 5. So I have 5 root 7 plus, when 3 divide 21, I have 7 divided by what? 18. So if 3 can divide itself is 1, divide this is what? 6. So I have 5 root 7 plus 7 all upon what? 6. That's what I will have. All upon 6. That's my answer. That's my answer. I can still go further. This 6 is a common denominator for this and this. Someone can still write this, or 5 root 7 over 6, because this 6 is dividing everything, plus 7 over 6. So this 6 is for this, and this 6 is for this. So I can still put it in this form. Yes, I can still put it in this form. Oh, this is sweet. This is sweet. So let's take the third question. The third question. I'm cleaning the steps now because I believe that it has become part of you, of living it again. So we have question number 3. We have 2 square root of 3 minus square root of 5 divided by 2 square root of 3 plus square root of 5. Okay? Now, we take note of the sod, which is 2 square root of 3 minus square root of 5 all upon 2 square root of 3 plus square root of 5. Okay? Now, we will find the conjugate of the denominator. The conjugate of the denominator will be obtained by just removing this positive sign now, changing it to the opposite side. So I have 2 square root of 3 plus square root of 5. What will be the conjugate of 2 root 3 plus root 5? Is going to be 2 root 3 minus root what? 5. We have said that to find the conjugate of a binomial, we change the sign, separating the two terms to the opposite side. So here the sign is plus. To find the conjugate of this sort, I will remove this positive sign and put a minus sign. So this is our conjugate for the denominator. And it is this conjugate that we are going to use to multiply what? The numerator and also the what? The denominator. That's the conjugate. That's what we are going to use. So we have this 2 square root of 3 minus square root of 5 divided by, okay, let's multiply it from that side. This will be times they multiply by the conjugate of the denominator, which is this. That's the conjugate of the denominator. So I will use it to multiply this and this. So I'll have 2 square root of 3 minus root 5 all upon 2 square root of 3 minus square root of 5. Okay? Oh, beautiful. We move on. So this times this will be 2 square root of 3 minus square root of 5 times 2 square root of 3 minus square root of 5. You see, I did not apply that principle, the principle that we have been applying for conjugates, because this and this are not what? Conjugate. It's this and this that are conjugate. You can see the difference between them is just the sign separating them, so they are conjugates. They are conjugates. Okay? So let's continue. If we now multiply, we have just brought this together in multiplication. So let's multiply this. Because this and this are conjugates, we have 2 square root of 3 squared minus square root of 5 squared. Remember, to multiply binomial conjugate, square the first number, use it to subtract the square of the second number. Very simple rule. So here, the first number is 2 root 3. Square it. The second number is what? Root 5. Square it and subtract them. So here, the same thing here. The first number is what? 5. I squared it. Minus, the second number is root 7. The first number is 5. I squared it. The second number is square root of 7. I squared it and then subtract. Just a simple rule, and that's what I will apply here. Remember, this rule is only applicable for binomial conjugates, when you have binomial conjugates. Okay? So I can expand this. This will multiply this. If you have watched our video on multiplication of salt, binomial salt, you understand it. That should be part 7 of salt. Part 7. So we have 2 square root of 3, which is this, times this, times 2 square root of 3. Okay? Then this again will multiply this. So this is positive. Times this, we have minus because of this. 2 square root of 3 times what? Square root of 5. I've used this on this and this, so let me use this. Minus 5 times this, minus square root of 5 times this, I have minus square root of 5 times 2 root 3. And then minus square root of 5 times minus square root of 5. The minus will multiply this to become plus. I have root 5 times square root of 5. Divided, that's just the numerator that I expanded. So divided by this squared minus this squared. Let's do 2 root 3 all squared. It means this will multiply itself. That's 2 root 3 times 2 root 3. That's the implication. And 2 is ordinary number, 2 is ordinary number. So 2 can multiply 2 to have 4. Square root of 3 can multiply square root of 3 to give us 3. Yeah, because a radical multiplying itself will give us the number in the radical. You have heard that before. I've said it so many times. So 4 times this will give us what? 12. So the whole of this now, which is this, will result to what? 12. Minus the whole of this, square root of 5 all squared, will be square root of 5 times square root of what? 5. And when we do that multiplication, we'll be left with what? 5. Okay, so the whole of this now is just ordinary 5. Oh. We move further. If we multiply here, 2 times 2 is 4. Square root of 3 times square root of 3 will give us 3. I just want to be taking time to do this. Nothing stops us from just saying this is 12. No, but let's take our time. So 2, this will be minus root 3 times root 5 will give me square root of 15. Thus we have 2 root 3 times square root of 5. These 2 are radical, so we can bring them under a common square root sign as 3 times 5. And 3 times 5 is 15, so this becomes 2 root 15. That's what we have here. Okay? We move again. Let's look at that. Minus root 5 times this will give us what? Will give us minus square root of 5. Already we have minus here. times 2 root 3. This will still multiply just like we have here. 5 times this will give us 15. So we have minus 2 root 15. Then square root of 5 times square root of 5 will just give us what? 5. All divided by 12 minus 5. So the what? 7. 4 times 3 is 12. Minus 2 root 15 minus 2 root 15. You know what it's going to be. If you have done addition of and subtraction of sort, you will understand. That will give me minus 4 root 15. Then I have plus 5 divided by 7. I cannot use this to subtract this because they are not like terms, they are ordinary. This is sum, but this is ordinary number. But 12 and 5 are ordinary numbers, so we can add them. So this should be 12 plus 5 minus 4 root 15 divided by 7. I just brought this closer to this. Yeah. So now I have 12 plus 5 to give us 17 minus 4 root 15 divided by 7. Okay? There's no common factor here. So you see, we cannot simplify further. But I can decide to write this alternatively, just like I did here. This 7 is a common denominator for these 2 terms. We have 2 terms here separated by subtraction sign. So I can write this as 17 over 7 minus 4 root 15 over 7. Oh. Beautiful. You can see that. You can see that we just took time to break this down so that you understand it. In case you still have difficulty trying to solve these problems, you can contact us. Very important. Just contact us. Our numbers is always on the screen. You can send a message to us, to our messenger. You can also email us. You can also send a message on our WhatsApp, and you can chat us up on our Facebook Messenger. We will be there to attend to you. Thank you for following us. Yes, I believe that you enjoy today's meal. But I will not be carried away. I know that there must be take away question. All right, let's have some pizza for today. So take away question. Take away questions. Let's have that quickly. Let's have the takeaway question quickly. Take away questions. That's our pizza. Let's have pizza for today. So they say simplify by rationalizing the denominators. Simplify by rationalizing the denominators. Okay, just 3 questions will be okay for all of us. For you and for me. So we have square root of 3 plus square root of 5. All of 1 square root of 5 minus 2. 2 root 5 plus square root of 3 divided by 2 root 3 minus 3 root 5. Okay? Question number 3. We have 5 minus 2 root 2. All of 1. 5 plus 2 root 2. Okay. So far so good. I believe that today's meal is very enjoyable. Till I come your way next time, please keep watching our videos. Keep sharing our videos. Keep commenting on our videos. Always like our videos. And do well to contact us in case you need help in physics, chemistry, biology, or mathematics. There is a series that is coming up soon. That series will center on UTME. That's the exam organized by JAMB. the series will be tagged JAMB 400. Yeah, JAMB 400. Don't ask me why we call it JAMB 400. Is it possible to have 400 in JAMB? I know some of you are shouting, it's not possible to have 400 in UTME. Well, it's not possible, but we'll be having JAMB 400, and in JAMB 400 we'll be reviewing a lot of questions in UTME, and we'll be solving them. Not just to solve them, we'll help you to understand the principles or the topic behind that particular question. All right, thank you, and God bless you. Have a wonderful day.